Now, another thing we can do with ratios and proportions is develop a scale or set up scale models. And we can use a scale um, when we've got a situation where maybe something's too large or too small to actually work with it in its actual size. And so a good example of this is like a model airplane, which is what our little word problem here deals with. So we're developing a model airplane, but we want it to be to scale. We want it to be the same proportions as the actual airplane, and obviously we can't often deal with building a real airplane. Certainly, you're not going to build one in your living room. And so here we've got a problem. It says on a model airplane, the scale is 5 centimeters, and that equals 2 meters. So our scale is 5 to 2, 5 centimeters to 2 meters. And so if the model wingspan is 28.5 centimeters, what is the actual wingspan of this airplane? And so again, we want to be consistent where we develop our ratios. And so I can then say that we got a scale of 5 centimeters, and on that scale, the model's wingspan is 28.5. Now, the actual size is in 2 meters. We got a scale of 5 centimeters. Let me put centimeters here to 2 meters. And we're trying to find out what's the actual wingspan. Let W be our variable. We're going to set W up as our variable for the wingspan. And again, we're dealing with ratios and proportions, and so we're just going to use the cross product. And so over here we got 5W. Let me change colors on this thing. That's too light. 5W equals, let's see, what's 28.5 times 2? Let's see, 28.5 times 2 is 57. Now, as far as our unit of measurements, here in this ratio, the centimeters are going to cancel, and we're going to be left with a meter when we find for W. And so let's say now all we got to do is divide both sides of this equation by 5. And so in a scale where we got a 5 centimeters to 2 meters, and the wingspan of the airplane is 28.5 centimeters, let's see, 57 divided by 5, and that comes to 11.4. Now, what's our unit of measurement? Well, it's going to be meters. This is going to be the actual size of the airplane's wingspan. Let's see, a meter is roughly, that's 3 feet 3 inches. And so we're talking, let's see, 3 times 11, 33, 4.4, probably about 34, 35 feet long. All right, well, there you go. Again, let's be persistent. We want to set it up again where we put our scale. We could do it the opposite way, and we could have put 28.5 over 5 and our variable over 2 meters and cross multiplied. We'd come up with the same answer. We just want to be consistent when we develop our ratio and set them up as proportions.